of algebraic graphs. We're focusing on 2 types of algebraic graphs today. The first type is the type that you're really quite familiar with. The first type of algebraic graph is called continuous. C-O-N-T-I-N-U-O-U-S. Continuous. And a continuous graph continues, right? Like it's in the name. It's connected. It's a line. If I was going to make a graph of my hair growing, it would be a continuous graph. Because, I mean, it's always growing. Maybe growing really, 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 really slowly. If I was going to graph the number of miles my car has driven, it's going to be a continuous graph. My car doesn't just magically go from 1 mile to 2 miles. It goes from 1 mile to 1.1 miles to 1.2 miles to 1.3 miles, right? Continuous. Discrete graphs Discrete graphs are the second type of graph. A continuing graph is connected in its lines. Discrete, is dotted. Or it's made up of points. Individual points. If I was going to talk about the number of cupcakes my store sold, right? I have a cupcakes shop, and no, I don't. But I wanted to graph the number of cupcakes I sold. I would not make it a line graph. Because if Landon came in to me and said, oh, your cupcakes are $2 for 1 cupcake, well, I have $5. So could you please just give me 2.5 cupcakes? I'll just take half of that one. Okay, just cut it in half. No, cut cupcake, right? That's not what's going to happen. You don't go in and say, oh, excuse me, I only have this much money, so I'll just take 4 1/3 apple. Just cut me off a little extra. Right? Discrete graphs are whole units. When I have to figure out how many buses I need to order for a field trip, take the total number of students and divide by however many students fit on a bus. And if it turns out that I need 12.7 buses, I have to round up to 13. I can't say, oh, excuse me, I would just like to rent out 7/10 of that bus. Discrete. It's not connected. They are distinct points. And the fun/aggravating part, depending on your personality, is that if you can make a good argument behind why you created that graph, it works. Here are some graphing practice. All right, so I'm going to split it in half, and I'm going to go about 8 lines down. 2, 4, 6, 8. So if we look at this, we know we have a discrete graph, which is dotted, individual points, right? If I was going to say the number of the average number of students in my classes, right? If I was going to figure that out, I don't want to go around talking about 0.5s of a student. I mean, I can. When you look on Shawnee Mission's website and it talks about the teacher to student ratio, it has a decimal in it. But that doesn't mean that teachers are teaching a decimal of a student. It means some people's classes are larger and some people's classes are smaller, and when it averages out, it's not an even number. All right, so let's talk. Julie slowly increases her speed. Then stops to rest. Next, she sprints home. Julie slowly increases her speed. Next, she stops to rest. Then she sprints home. Now, again, this graph has a couple, or this story has a couple of graphs that would work, and we're going to talk about them. You just have to be able to make the correct argument, a valid argument, about why your graph works. Because if I was going to make one graph, the first one, I could do, now I'm going to turn this so that I can write sideways on my axis. I could do distance from home. Right? And I could do the overall time, which is going to be pretty consistent. So Julie starts at home, and she slowly increases her speed. So it's going to go up. Do you agree? But it's going to be pretty slow, so it's not going to be really steep. It's going to be like this. Maybe a little bit steeper. It's your choice. And then she stops to rest. So is she still moving away from her home? No. So maybe I'll make this a little bit longer. And then she stops to rest. So what's going to happen? Does it go down? Does she get closer to home? It's going to be a straight line. Stops to rest. And then she sprints home. So she's getting closer to home. So I'm not going to keep going up. I'm getting back to home, right? So, but it's going to go sharply down because she's sprinting home. That's one graph that would represent this. I could also make a graph about time, and this one in pink is going to be her speed. And if I was going to measure her speed, I'd probably follow the same thing here. But when it comes time for her to stop to rest, what happens to her speed? It goes whoop. Right? Maybe she did a little cool down. Probably not. And then what happens when she sprints? Straight up. Or, yeah, like pretty quickly up, right? And then when she gets back home, what happens? Yeah, she's going to stop again. Two completely different graphs, correct? But my two completely different graphs, one of them is comparing the speed, right? And the other one is comparing the distance. But both work for that situation. You just have to make sure that your labels are right. Do you see what I mean by making good arguments about what you're doing? All right, so now let's talk discrete graphs, distinct points. Let's talk about Simon sells candles. for $2 each. Yeah, I could make a graph about Simon, yes? What could my graph about Simon look like? Is it going to be connected? Does Simon sell you 1.5 candles? No. Simon's going to say, get out of here, crazy pants. If I put the number of candles down here, 1 candle, 2 candles, 3 candles, 4 candles. And over here is my money. One candle is $2. 2 candles is $4. 3 candles is $6. 4 candles is $8. If Reagan said, oh, I have $7.50, what can that get me? Simon's going to say 3 candles. There's no between. That's discrete. Versus continuous. Now, if you took this same exact amount and you wanted to compare if Simon sells candles for $2 each, but you wanted to know how much money Simon made, it would be discrete or it would be continuous, because Simon does not just make $3 and then $4. Nope. $4 and then $6. That's what I meant. Because he does have $5, right? He does have that amount in between. It's not like there's nothing between $4 and $6. He has the money. Once he gets to $6, he has $5.99, $5.98. He has all of that between it. But his inventory going out is discrete. His money coming in is continuous. So if you're given a story, you're going to be drawing a quick graph. It doesn't have to be beautiful. But what if you're given a graph? Can you write a story? So, we're going backwards. We're not going to draw a graph. We're just going to talk about hypotheticals. Writing the story. So when you're writing the story, if you're given a graph and you're told to write the story, you want to break the graph into sections. And there are 3 sections or directions the graph might be going. You're going to break the graph into sections. And then you're going to match the section with a word and look at the labels. I will tell you this, the labels are the thing that you guys skip over the most. I'm reading a story about a graph and it's talking about like the number of puppies at the park, and then you look at the label and it's like cans of Coke consumed at a baseball game. You're like, oh, well, you obviously didn't read the words. I appreciate writing about puppies, but the labels are there for a reason. Shocking, I know. All right, there are 3 sections, 3 directions. There's up, there's down, and there's flat. There's up, there's down, and there's flat. Up, down, and flat. Who's got some words that could tell me about a story going up? If the graph is going up, what's a vocabulary word, a synonym that you could use for up? Increases, increased, any type of... Up. Increase. What else could mean up? What if you're talking about speed? Faster? What if you were talking about weight? Heavier, gained, heavier. Bless you. What if you were talking about height? Taller, grew. Do you see what I'm talking about? I mean, there are a lot of words that could show why a graph was going up. What are some words for down? Decreases. Slows. I mean, the opposite of these words, yes? Slows. Loses. What? Lighter. That's a homonym. I was like, what? A lighter? Why are you lighting something on fire? And then I thought to myself, no. Not as heavy as. Something fell, right? Shorter. Declines. What about flat? What could a flat graph be described as? Depending on what the situation is, it could be straight. Could be stopped, right? Could be the same if you're talking about speed. If you're accelerating and then you're staying at the same speed, or you're leveling out, right? Pausing, maybe. But sometimes pausing or stopping, depending on what your labels are, could mean an immediate stop, a vertical line down. It just kind of depends on what that looks like. Resting. Good. Now let's look at this yellow page. Here are even more descriptions. And sometimes you can put, what would that be? Ends in ly, an adverb with it. So you could say steadily decreased, slowly or gradually decreased, depending on how steep your line is going up or down. But if I was going to write the story for this, my rules, remember, were to break it into sections. So I would have one description right here. And this doesn't even have labels on it, so I could make my own up. But if I was talking about the speed of my car on my commute home, I could say this is me getting onto the highway, right? I'm going down the entrance ramp to the highway, so I'm increasing my speed pretty quickly because I have to get up to highway speeds pretty fast. And then right here for section number 2, I had to slow down a little bit because there was some traffic. Right, there was traffic ahead, so I slowed down to see what was going to happen. And then here, I'm being a crazy driver, weaving in and out of traffic, trying to get the best spot that I can. So I'm going real fast, then I'm stopping, then I'm cutting somebody off, then I'm staying still for a little bit. Right? Don't drive like this, kids. Don't be that person. And then the traffic calmed down. Everybody got with the program, so I stayed at the same speed. And maybe here I wanted to pass a car to get to my exit. So I increased it pretty quickly. But then I saw that there was more traffic in front of me, or there was an accident, and I had to slow down really quickly. And then I'm stuck in traffic trying to get around, but I finally have to come to a standstill because the highway's closed. Or maybe I got home. Maybe I got off the highway. And this is me slowly making my way through my neighborhood. But there would be 7 descriptions in this graph. All right, let's go easy. 2 phrases that could describe this graph. This guy right here. It's continuous. What are 2 phrases that could describe this one right here? Increases. What else could describe that graph? Rose. Grew. Rose. Climbed. Is it steep? Is it quickly or is it slowly? Yeah, this is going to be slowly. All right, show me a graph. Number 2. Sketch a graph that shows the speed of a car decreased dramatically and then remained constant. Well, is my graph going to start at 0? No, my graph does not start at 0, and that's another tricky part sometimes. We always want to start at the origin, but in order for it to decrease, it's got to start somewhere, correct? So decreased dramatically. It's going to be pretty steep going down. And then remained constant. Straight across. All right, let's match. We have 3 graphs, and we have 3 situations. Graph A. Which one is graph A? The baby lost a little bit of weight and then gained weight back slowly. 4. Yep, is A. B. A baby gained weight at a rapid pace. A baby gained weight at an uneven pace and then maintained a constant weight. 3 is C. Do you see how those 3 graphs are represented